Okay, let us discuss about one of the most popular and important network theorem called Thevenin's theorem. So in many practical applications, it is always not necessary to analyze the complete circuit. It requires that voltage, current or power in only one resistance of a circuit you may have to find. That is, you may want to find. So in such situations, Thevenin's theorem is applied. It states that any two-terminal linear network having number of voltage current sources and resistances can be replaced by a simple equivalent circuit consisting of a single voltage source in series with a resistance where the value of the voltage source is equal to open circuit voltage across two terminals of that network and resistance equal to the equivalent resistance measured between terminals with all the energy sources are replaced by their internal resistances. So this is a basic definition. Let us solve one small example so that you will better understand what exactly is to be done. So if some such simple circuit is given, we are considering a very small circuit at present. What we want to do is we want to find out Thevenin's voltage and Thevenin's equivalent resistance, where the points mentioned are A and B here. So across this we want to find out. Now we can see here simple theory. So this is your 10 volt, this is 2 ohm, 12 ohm and 24 ohm. Say for example, if we want to calculate current flowing through this particular 24 ohm resistor, then how we will do is I24, that is current flowing through 24, will be equal to I total, that is whatever current coming here, into other resistor. So here we will apply current division rule. So current coming from this, that is IT, into other resistor, that is 12, divided by 12 plus 24, that is 12 plus 24. And then you can simplify this. IT is 10 divided by 2 plus 12 parallel 24. So this equivalent and is equal to, say for example, coming out to be 1 ampere. First of all, IT, how you are calculating? 12 and 24 parallel in series with 2. So and the voltage applied is 10. So 10 divided by total resistors. So total resistance is 12 parallel 24 and then plus series this particular 2. So it is 10 by 10 1 ampere, and I24, that is current flowing through this 24, will be total current, that is 1 ampere into 12 divided by 12 plus 24, that is coming out to be 0.33. This is our conventional method. And voltage across 24 ohm resistor will be 0.33. This is I into R, that is 7.92 volt. Now what we want to do is we will apply Thevenin's theorem, and how you will get it, just see. So first of all, we will calculate Thevenin's voltage. So Thevenin's voltage VTH, that is open circuit voltage. Here we want to find out open circuit voltage. That will be 10 into, now in current division rule, we consider the other resistor in numerator. Now here what we want, open circuit means drop across this 12 ohm. So therefore the resistor across which we want the voltage drop, that resistor itself will appear in the numerator. That means 10 volt, 2 and 12. This is our actual loop where we are going to apply the voltage division rule. So 10 volt is a voltage source, drop across 2 and drop across 12. So if you want to find out drop across 12, then you will write the equation total voltage, that is 10 into the resistor which is coming in picture divided by total resistor. So total resistance is 12 plus 2, that is 14. This 12 plus 2, 14, and drop across 12 is 12 into 10 divided by 12 plus 14, that is answer coming out to be 8.57 volt. So this is our open circuit voltage, that is called VTH. And now what we want is RTH, that is equivalent resistance. Now for this purpose, what we are supposed to do is remove this 24, that is open here, and look back into the circuit. And in this situation, wherever the energy sources are there, that is this is a voltage source, is to be replaced by its internal resistance. Since internal resistance is not given, that means it is 0, and that's why this voltage source should be shorted. So therefore the resultant RTH will be directly, this is shorted. So therefore 2 and 12 will be parallel. So 12 into 2 divided by 12 plus 2. So this is a calculation, 12 into 2 divided by 12 plus 2. It is 12 into 2 divided by 12 and 2 are in parallel. This is going to get shorted. Therefore 2 and 12 will be parallel. And the resultant resistor coming out to be RTH, that is 1.71 ohm. And now if you calculate, then just a moment, what I need to do is just a second. So this is, so I24 is equal to 8.57 is a voltage divided by 24 plus 1.71, because this is our RTH, this is our VTH, that is VOC, and the current flowing through this loop will be I24 ohm. Same current will flow through this RTH and 4 ohm resistor, our interested resistance. So 24 plus 1.71 total resistance, and voltage is 8.57. So current coming is 0.33, and drop will be again 24 multiplied by 0.33, that is coming out to be 7.92. So whatever we found from conventional method, same thing we are going to get with this another method. Now same fashion, here you can see one more example. So 50 volt battery, 10 ohm, 5 ohm, and we want to apply Thevenin's theorem here, middle portion, and this is one more source, 25 volt. So VTH is VAB, and RTH is resistance which is seen into terminals AB. So for VTH, if we want to solve, then this whole we will consider this is open circuit. Therefore, this is 50 minus 25 is equal to, suppose I current is flowing 10I plus 5I. So these two are in, like, this is minus plus and this is coming out to be plus minus, or here minus to minus. Therefore, we have to do the subtraction. So 50 minus 25, and current flowing through this 10 and 5, same direction, 10I plus 5I. So total I is coming out to be 25 by 15, that is 1.67. So voltage across 10 ohm, this we want, voltage across 10 ohm will be 10 into 1.67, that is 16.7, and voltage across 5 here, that will be equal to 5 into 1.61, that is 8.35 volt. Now we want VTH, that is VAB. So VAB will be this 50 minus drop across this, that will be your voltage. So here it is 50 minus V10, that is 50 minus 16.7, 33.3, and RTH will be equal to this RTH. This is shorted, this is shorted, therefore 10, and this is open, here it is open. So 10 and 5 will be parallel, not in series, end to end connected. Here end, one end connected, and this is the another end connected. So 10 and 5 will be parallel, and therefore it will be 10 into 5 divided by 10 plus 5, that is equal to 50 divided by 15, 3.33 ohm. So this way you can calculate VTH and RTH.